This is Mrs. Rubright with Advanced Geometry. Today's lesson is 4.9, Perform Congruence Transformations. Alright, so name the type of transformation demonstrated in each picture. So what's going on with this first one? It is being reflected over a horizontal line H, reflected over the horizontal line H. Alright, how about here? A rotation. It is being rotated about point P, clockwise, right? Rotated clockwise about point P. What's going on here? Translation to the right. On here. Reflection, right? It's being reflected across the water, across a horizontal line. Alright, so figure ABCD has the vertices A at -4, 3, B at -2, 4, and C at -1, 1, and D at -3, 1. We want to sketch ABCD, so here's ABCD. And then we want to sketch this image after a translation. Here is a rule. This is a translation rule, right? Here's the rule. So what's going on here? We are going with your X in the positive directions to the right, in the negative directions to the left. So this is right 5. And then for your Y, it's up and down. If it's plus, it's up. If it's minus, it's down. So this is down 2. So right 5, down 2. So you take each of these points and you go right 1, 2, 3, 4, 5, down 1, 2, and your A prime should be around there. Right 1, 2, 3, 4, 5, down 2, B prime. Right 1, 2, 3, 4, 5, down 2, C prime. Right 1, 2, 3, 4, 5, down 2, D prime. Or you could use your rule and just do the addition. So -4 plus 5 is 1. 3 minus 2 is 1. So 1, 1. -2 plus 5 is 3. And 4 minus 2 is 2. -1 plus 5 is 4. And 1 minus 2 is -1. -3 plus 5 is 2. And 1 minus 2 is -1. And so you can get it using your rule, or you can get it by using the fact that it's right 5, down 2. Is everyone clear on this? Do you understand what I mean by right 5, down 2? Go to the right 5, and then go down 2. You are drawing a pattern for a wooden sign. Use the reflection in the x-axis to draw the other half of the pattern. Alright, so if I'm reflecting over the x-axis, this is on the x-axis, it stays on the x-axis. On the x-axis, it stays on the x-axis. This point is 1, 2 to the x-axis, 1, 2 away from the x-axis. This point right here is 2, 2 away. This is 4, so 4 away. If you go to here, it's on, we can just connect. Or we can go like here and like 2, 2 away, and so on. Does that make sense? So that's reflecting over the x-axis. You can also use a rule. So when you're reflecting over the x-axis, your x value stays the same, opposite y. X value stays the same, so 1, 2 becomes 1, -2. 1, 4 becomes 1, -4. 1, 2, 3, 2 becomes 3, -2. So the rule is same x, opposite y. Make sense? Alright, so graph segment AB and segment CD. Tell whether CD is a rotation of AB about the origin. If so, give the angle and the direction of rotation. So, the first thing we're going to do is we're going to graph A and B. So we have our points at -3, 1 and -1, 3. We have our other set of points at 1, 3 and 3, 1. So, the easiest way to do a rotation is your rotation rules. And so I'm going to fast forward this to our rotation rules so that you guys can copy them down. So, the first thing I want you guys to do is I want you to copy this all down, and then we're going to go into depth on exactly what this means and how to do it. So first, copy this down. Give yourself a line or two between each of these so that I can give you some extra information to fill in once you have this copied. So pause the video. Take some time to copy this, and then we will go back. Alright guys, so you should have copied this by now. So 90 degrees counterclockwise rotation. you're going to switch the x and the y and change the sign of the new x. So for example, if I gave you the point 1, negative 2, okay? You're going to switch the x and the y, change the sign of the new x. So you're going to have 2, 1. So let's just draw what this looks like. So if you had 1, negative 2, that's your, we'll call that point A. Your A prime is going to be 2, 1. Well, let's look at what this does. All right, so that's 90 degrees, and you're going counterclockwise, the opposite direction of a clock. Does that make sense? 90 degrees counterclockwise. So 90 degrees counterclockwise is the same thing as 270 degrees clockwise. So 90 degrees counterclockwise is 270 counterclockwise. 90 degrees counterclockwise is 270 counterclockwise. Or sorry, clockwise. Why did I say counterclockwise? Okay. Clockwise. 270 clockwise is 90 counterclockwise. 90 opposite way to the clock, or 270 the same direction as the clock, right? So our rules are always in counterclockwise unless they say otherwise. So if they tell you to do a rotation is always, always, always counterclockwise unless they specify otherwise. Unless they say clockwise. Does that make sense? All right, so let's look at the next one, 180 degrees. So on this one, keep them the same, but change both signs. And we can call this A and A prime, right? So if you had A is at 1, negative 2, and it's going to go to A prime, and it says leave them alone, so 1, negative 2, and then it says change both signs, so negative 1, positive 2. So let's look at this. We have 1, negative 2, that's our A. Our A prime is negative 1, positive 2. Let's see what this looks like. So we're going to compare to the origin. Do you guys see this is 180 degrees? 180 degrees in either direction. Oops. We're starting here. We're starting at A. So going this way is clockwise, this way is counterclockwise. It doesn't matter clockwise or counterclockwise, it's going to be 180 degrees either direction. So 180 degrees clockwise or counterclockwise, right? It's the same for both. Let's look at our next one. So on this one, 270 degrees counterclockwise. Switch the x and the y, change the sign of the new y. So your A is at 1, negative 2. When we apply 270 degrees counterclockwise, we get our A prime, our image of A. And our image of A, switch the x and the y, change the sign of the new y. So we have 1, negative 2 becomes negative 2, negative 1. Let's check this one out. 1, negative 2, that's our A, becomes negative 2, negative 1. Let's see what's going on here. So we can see that that's 90 degrees. We're going from A, counterclockwise. It's 270 degrees counterclockwise, which is the same thing as 90 degrees clockwise, right? So 270 counterclockwise is 90 degrees clockwise. You guys understanding this? Yes? So you have to memorize these rules. So just to recap, our rules are counterclockwise unless they say otherwise. So our counterclockwise rules, 90 degrees, switch the x and the y, change the sign of the new x. 180, leave them alone, change both sides. 270, switch the x and the y, change the sign of the new y. You have to have these memorized. So going back to page 3. I think it was page 3. No, we were further than that. We were on this one. All right, so first, we plotted the points, right? Let's see what rule this would be. So -3, 1 is becoming 1, 3, right? A is becoming C. So you're going from -3, 1 to 1, 3. What's going on there? Switch the X and the Y, change the sign of the new X, right? Switch the X and the Y, 1, -3, change the sign of the new, oh no, it's the new Y, right? Change the sign of the new Y. So what's that? 270, right? Counterclockwise. Let's double check on the next points. So point B is at -1, 3, and B is becoming what? D, 3, 1. All right, 1, 3 to 3, 1. Switch the X and the Y. Change the sign of the new Y. Yep, that's what's going on there. So it's definitely 270 counterclockwise. And let's look at the picture. Does this make sense? All right, so we're going from A to C. So that's definitely 90. That's 90 clockwise, which is 270 counterclockwise. Make sense? All right, so identify this rotation. Well, going from A to C, one has a 0 and a 1, this has a -1 and a 1, so they are positively 100% not going to be a rotation because you have different numbers there. And if you look at B and D, once again, you have a 1 and a 3, you have a 2 and a 3. They are not the same numbers, therefore they're not going to just be like switched and have signs switched because they're different numbers. So it's definitely not a rotation. All right, so the vertices of triangle ABC are as follows. A is at 4, 4, B is at 6, 6, and C is at 7, 4. The notation of XY becomes X plus 1, Y minus 3. This is going to be a right 1, down 3. Describes the translation of ABC to DEF. Show that ABC is congruent to DEF to verify that the translation is a congruence. Okay, so we're just showing that things are still the same. So going from A to D, all you did was you went right 1, down 3. For B, you went right 1, down 3. For C, you went right 1, down 3, and so on, okay? So we know that it's definitely, if it's just being translated, it's obviously staying congruent, but they want us to actually prove this. So, 1, 2, 3. This is a side length of 3. This is a side length of 3, right? So they have those tick marks saying, hey, dude, we're equal. This is, if I did a cute little Pythagorean theorem here, I'd have 2, 2, 2 rad 2, right? It'd be like 45, 45, 90, x, x, x rad 2. So this is actually 2 rad 2. This is 2 rad 2. This angle here is the same as here and here. They already have the tick marks, so they don't really actually even need you to solve for these measurements. All they're really saying is, why are they congruent? Well, they're congruent by side, angle, side, right? Side, angle, side. Because they already made the marks for you, so they did all the work for you. But if you wanted to prove their actual distances, you could, because you have those coordinates. You can throw it into the distance formula. You can do a cute little Pythagorean theorem. So that's kind of neat. Tell whether triangle PQR is a rotation of triangle STR. If so, give the angle and the direction of rotation. All right, so our P is at 1, 2, 3, -3, right? And our S is at 3. So this is definitely like 180 degrees here, right? A rotation of 180. Let's see about these. Aren't these 180 degrees? 3 by 2, 2 by 3, right? Those are going to be the same distance from the origin in keeping to the 180 degrees. This is a 180 degree rotation. Okay, and it can be counterclockwise or clockwise. It doesn't matter because 180 goes both ways. And those are your rules. So that is everything that you guys needed to learn today on 4.9, Perform Congruence Transformations. I hope you guys enjoyed the lesson. Please like and subscribe and have a wonderful day.